Okay, class. So, sphingomyelin, I would like to tell you over here. Sphingomyelin, if you remember ceramide, in ceramide at position number 2, your fatty acid carbonyl group was, associating with the amino group. So, what happened is that you keep on that structure continued. Position 3 is okay. Position 3 is no changing. Position 2 is again no changing. This is just like ceramide. Now, in position number 1, you have replaced H. CH2OH. So H is being replaced by phosphatidylcholine. If you remember choline, so this is the same choline which was earlier you have studied, phosphatidylcholine or phosphatidylethanolamine. So either it is replacing by choline or ethanolamine. So they are the constituent of the plasma membrane also. So you just don't need to remember it too hard, because if you remember phosphatidylcholine, if you remember phosphatidylethanolamine, I have described it yesterday also. So they were the type of that phospholipid. So if you replace this H with that phosphatidylethanolamine or phosphatidylcholine, you will get sphingomyelin. So sphingomyelin, which is having a phosphatidylcholine head group, is very much similar in size and shape to the glycerophospholipid phosphatidylcholine. Okay, so just remember this. Okay, so next one is a cerebroside. So what is a cerebroside? It is just a sphingolipid, ceramide, where you are adding a monosaccharide such as glucose or galactose as a polar head group. So ganglioside is a ceramide with a polar head group which is a complex oligosaccharide. I'll be showing you over here. I'll be describing this in the class also. So you can see the cerebroside. This is again ceramide. Position 3 is okay. At position 2 you have seen again. Now CH2OH, फिर H हटाओ. देखो सारा खेल वही है. पोजीशन 1 पे अभी फॉस्फेटिडाइलकोलिन लगाया था पिछली स्लाइड में, तो तुम्हारा देखता हूँ, बताता हूँ मैं. एक मिनट, जस्ट गिव मी अ मोमेंट. Look at this, right? So this is sphingomyelin. Now if you change it with a carbohydrate, suppose beta galactose, right? So it suddenly change its name. It is cerebroside, right? Where it is they are collectively called as glycosphingolipids because carbohydrate comes, and I told you earlier that carbohydrates jahan bhi aayega it becomes glyco. So glycosphingolipids, they are also found in the outer leaflet of plasma membrane with their sugars extending from the outer cell surface. Okay, so this I have already discussed regarding micelles and bilayer. This is a common property of these kind of lipids. Yeah, membrane fluidity. You should know, students, that interior of all the lipid bilayer is generally highly fluidic in nature. So what happened is that during liquid crystal state, which is this one, the first one, the phospholipids, the hydrocarbon chain of phospholipids are disordered and are in a constant motion. You can see this distorted form. तो जो hydrocarbon tail था, that was in a constant position. अगर वो you just can see, if it keeps on moving, it will be in a liquid state. So what happened is that lower temperature, the membrane which contains single phospholipid, it undergoes a crystalline state where the fatty acid tails are completely extending itself, right? So that it should become highly ordered, and van der Waals interaction between adjacent chains are becomes maximum. So what happened is that from the normal temperature to a lower temperature, it moves towards the crystalline state. So these are the two states: liquid crystal and the crystalline state. Okay, fine. So kinks in the fatty acid, as I told you earlier, due to the double bonds, is interfering with the crystalline state and lowers the transition temperature. Now cholesterol is my next topic of discussion. So I'll be describing this in my class also. Thank you.